In this video, I'm going to give you an introduction to pulley system. All right. So let's see what we got here. Right. So first you can see here is a pulley. We're going to assume that this pulley as a smooth one and it should be fixed, right, somewhere here. So we assume the pulley is fixed and smooth pulley here, right? And we have a string which is passes through this pulley. Okay, so that string should be inextensible rope or string. So what this mean, inextensible? So essentially we have to assume that this rope, right, is not kind of stretching one, or if you understand like this, the length of this string not going to change, right, during this motion. Okay, so this is very important assumption. Now you can see two particles are connected to this string. Okay, so basically it's hanging in this string. Okay, now before we study this motion, we need to complete the force diagram. Okay, so let's see how we can complete the force diagram. Okay, so now here we can put the weight, right, of this particle here, right? So you have the mass m1, therefore the weight should be downward, vertically down, that's equal to m1g. Okay, so here you have a particle with mass m2, therefore the weight of that particle should be m2g. Okay, so now we have a rope here or a string here, right? So we need to put tension in this string. Okay, so how we can put that tension? We can mark it like this. Okay, and here this part in the string has tension. We can put it like this. Now what we need to know, right, if I take this tension, this side as T, right? Now what about tension of this part of the string? It's essentially should be the same. Why is that? When there is just one string or one rope, okay, everywhere in the string, right, applying same tension. Okay, so we need to know that, right? If there is same string or rope, right, has actually same tension. So that's important to know, right? So now we have this information about the masses, right? So m2 greater than to m1. If you release this system, what's going to happen, right? Definitely this particle should go down, right, as these two particles connected to each other. When this one go down, same time this one should go up. All right, so now with acceleration, because you can see there's resultant force applying on m2 as you have T external force, right? and it has m2g weight. So this particle moving with external force now. Therefore, this one should move with certain acceleration. We don't know that acceleration. Okay, so but we know the direction, it's moving down. We can take that acceleration as a, right? With the direction, I can show that here like this, right? It's moving with acceleration a, essentially it's moving down, right? So this particle moving up with the same acceleration, I mean magnitude of the acceleration remains same. Okay, so the acceleration is a, but the direction, as this one moving up, the direction should be vertically up. Okay, so that point also very important. Okay, so particles moving with same acceleration, they have same acceleration. Okay, so these two you need to understand. Okay, the rope has same tension everywhere, and both particle moving with same acceleration. All right, now what we're going to find here, we need to find the tension in the rope. We need to find tension. Now we take it as T, so same T here, sorry. We need to find T, and we need to find the magnitude of the acceleration. So we took it as A, so we need to find A. Basically, now we need to find T, tension in the rope, and we need to find acceleration of each particles. Right, so now let's do this. Now we understand each particles moving with acceleration, right? Therefore, we can use F equal ma. Now we can use F equal ma, right? Now F is the resultant force of the particle, m is the mass, a is the acceleration of the particle, right? So I'm going to write this F equal ma to each of these particles separately. Now let's do it for particle m1 now, right? We need to know this F equal ma is, we call as vector equation. Essentially, we need to consider the direction of F and direction of A when you use that equation. So therefore, when I write this equation to particle m1, so for this particle, I'm going to take moving direction as positive direction. So this one going up, right? Therefore, I take upward direction as positive direction. Essentially, all the forces upward we take as positive, all the forces downward we take as negative force, right? So acceleration the same. We need to consider the direction. Now, if you look this particle, it's moving up again. So T is in positive direction. So I can take T as positive, right? So if I take M1G, this force is vertically down. Therefore, it's take as negative force. And m, the mass of the particle, is now m1, And acceleration is A moving up, right, is in the direction. So we take as positive, right? I can write this equation. Okay, so I take this equation as equation 1 now. Now I'm going to write F equal ma again to particle m2, right? Now m2 is moving down, therefore I'm going to write F equal ma to particle m2 taking downward direction as positive direction. So this is particle m2. I'm going to write F equal ma taking this direction as positive direction. Now let's see all the forces applying on this particle. I can see m2g is downward, it's in positive direction, therefore that one is a positive force, m2g, right? If you look T now, T is vertically up, so therefore that force is now a negative force, right? I put minus T equal to, now m is the mass of the particle. Now we take in this particle, therefore the mass of that particle is m2, right? So what is the acceleration? A is now you can see downward, it's simple A, right? We write in equation downward, therefore we can take positive A for acceleration, right? So this equation I take as equation 2. Now our aim is to find tension T, right, and the magnitude of the acceleration. So that basically we need to find T and A. Okay, we have two equations involving T and A, right? So therefore we should be able to find T and A. If you solve these two equations 1 and 2 simultaneously, you can find T and A. Now if you look carefully these two equations, how we can find T and A, actually you can see if you add these two equations together, right, you can get rid of this T, because here you have positive T, here you have negative T. So if you add these two equations together 1 and 2, right, you can get rid of T, right? So let's write the result here. I know T is cancelling out now, therefore when you add these two terms we would get m2g, right, this negative m1g, left hand side. Right hand side we have to add together, we add in both the equations, therefore right hand side we are going to get m1a plus m2a. Okay, so now we don't have T in this equation, just unknown term is now A, right? We can find A. If I take common factor A out, I can write A times m1 plus m2 on the right hand side. Left hand side, if you want, you can take G out because G is a common factor. You can write this as m2 minus m1. I take G out like this. Now you can find A if you divide both sides by m1 plus m2, right? So that gives us A as m2 minus m1g over m1 plus m2. So that is the acceleration of this particle. Okay, actually we found A, that means the size or magnitude of the acceleration, right? Okay, so this is the acceleration. Now we have to find T, tension, right? You can use either of equation to find T now. As we know A, you can substitute A into here or here to find T, right? So you can pick actually the easiest one to find T, okay? So I need some space, so can I clean this here? We know now what we're going to do. Right? So now I take equation 1. I think this one is better one to find T, right? So from equation 1, you can copy that equation down here. You have T take away m1g equal to m1a. Okay, so now I'm going to substitute a from this result. So you can write T minus m1g, right, equal to m1a is this, right? You can write it from that, which is m2 minus m1 times g over m1 plus m2. Okay, so now what we can do is you can find T if you move this negative m1g into the right hand side, right? So now T is equal to, I move this one to right hand side, right? So here we have already m1, m2 minus m1g over m1 plus m2. When you move this negative term to the opposite side, it should become plus m1g now, right? So this is our T, but we can simplify this a little bit. Okay, so if you take m1 plus m2 as common denominator, right? To do that, you have to times this term by this, right? So let me do that. Here we have common denominator as m1 plus m2, right? And at the same time, I'm going to, because my aim is to simplify numerator, so I'm going to expand this term here. So that gives us m1 m2 g, right, minus m1 square g, right? If I expand this bracket, I would get this, and now I'm timesing this m1 plus m2 by this term. That gives us m1 square g, right, and m1 m2 plus m1 m2 g. That's what you're going to get on the top. Now you can see this m1 square g, and here we have negative m1 square g, and here you have positive m1 square g. Therefore, these two terms cancelling out, right? So what we have here, m1 m2g plus m1 m2g, right, on the top, right? So then if I take that to somewhere here, right? I'm going to get T as, now what we have on the top again, you have two lots of M1, M2G. So we can write it as 2 M1, M2G, right, over M1 plus M2. Okay, so now we know T, it's 2 M1, M2G over M1 plus M2, and we know acceleration A, which is M2 minus M1G over M1 plus M2, right? Now we found T and A. Okay, good.